Exploratory factor analysis primarily is the data reduction technique. So what exploratory factor analysis will do? It will group the very similar and correlated item. Now, these two are different things. Correlated means conceptually they are correlated, and similar means the response pattern of the respondent is similar. Doesn't matter whether they are correlated or not correlated. When the response pattern is very same, EFA will call it as the similar and will group together. When we say correlated, it means highest correlated will come at the one place. So the point here I'm referring to is EFA will differentiate between what is a construct and what is a factor. Remember, in EFA, how we start? In the EFA, we start with the items. Now here, whether you call it as the statement or item, one and the same thing. And as many items are there, as many factors will be made. And remember, factor is made, is constructed, is computed. Rather, let me write here the each. Each factor is computed using all items. A very biggest misnomer is people say these four constitute the first factor, these are the second, these are the third. No, it is not. My only point of discussion here is each factor is made or computed using all items. Then further, if I write from the total, subtract the factor 1 and from the remaining make the factor 2 so that these have a correlation of 0. Just so you can remember it with this, that factor 2 is constructed, is computed from residual. Remember this very important word, residual. Factor 2 is computed from the residual of factor 1. That's why factor 1 and factor 2 will have the 0. And this particular thing is called as PCA, principal component analysis. And this is what we will not use in the PAF. Just wanted to tell you these things because still there are the people who use this misnomer. Maybe they are not aware of, maybe they don't use it. Just see this. I have the 13 items or 10 items basically, 6, 7 are missing. So total 10 items are, or 11 items are there, my mistake. Total are the 11 items. I have taken a very small data of 50. Let me use the EFA. So factor analysis, the way we do, put all on this side. I'm working on the SPSS. These are my items. All items are taken on the 7-point scale. Total sample I have taken is the 50. So in the variable view, these are my 11 items. All items are measured on 1 is completely agree and 7 is completely agree and 1 is completely disagree. I must check if there are any missing value because SPSS doesn't like the missing value at all. So it says total are 50, no missing. Valid N is 50. There is nothing missing. Okay, valid N is 50. Now let's go ahead and work with the way we work generally. Keep all the items on this side. In the descriptive, it's okay. We should click on the KMO. You should click on the coefficient, etc. If you want anti-image is okay. Extraction should be more than one unrotated principal component. Remember, there are other methods also. We are working with principal component. Rotation, very max. Options, sort, press, and keep this value as something like 0.4, 0.5, and click on the OK. How to read it? KMO value should be more than 0.6 or 0.7. Bartlett test of sphericity significance should be less than 0.05. In the anti-image, go for this value, anti-image correlation. This value, there is a just below the table, read measure of sample adequacy. This is called KMO of individual item. KMO of individual item. Read the diagram, this diagonal value. So this should be more than 0.7. All are good. Eigenvalue should be more than 0.5. Yeah, almost all are good. Total variance explained should be more than 60. 77 is good. 3 factors are extracted. Leave the first table. This is the second table. Results are almost good, except there is a one item which try to say I am little highly loaded. Item number 4 is highly loaded. Rest values are okay. So we generally say item number 5, 8, 9, 10 is the first factor. Item 1, 2, 3, 4 is the second factor, third factor. This is my only point of submission. This is not so. Please don't say ever like this. This is the first factor, which is made up of all the items. The items which are highly correlated, high factor loading is called as the construct. So we will say first construct got highest loading with the factor 1. I repeat, first construct has a highest loading on the factor number 1. So factor and construct are little different. A factor is a combination of all. This table shows us high correlation of every item with every factor. But that doesn't mean these others are not there. Other values are there. And this one is computed using all of them actually. Okay, this is a sort of a misnomer. People often forget about this thing. So if you allow, I will just quickly show you how these tables are computed. I will take 5 minutes or so, or maybe 10 minutes. You just see. If you understand, perfectly okay. If you want to skip, absolutely no problem. I am just telling you what happens at the back end. So at the back end, these things are not required. At the back end, it will say, yes, use the principal component and create the as many factors as there are number of items. Since I have the 11 items, I will create the 11 factors. Okay, no rotation required, no press or this required, nothing is required. Just save them. Save with the regression method. Okay, done. Okay, one more thing actually will be helpful to me. Let me remove their names, etc., so that it will become very small. Yes, let me run it once again. Factor analysis, all these items are there. Okay, and these are, look at my table. These are my factors. These are my factors. These factors are computed 2 times because I ran 2 times. So these are the 11 factors created. Let's see how these factors look like. Look at the right hand side. These are the 11 factors. Okay, how these are created, we are not going for that sort of mathematics. So just remember, when you say run factor analysis, SPSS at the back end take its own computation methods and compute your factors. How many factors? As many factors as are the items. So if there are 40 items, there will be 40 factors. 80 items, there will be 80. I had 11 items, so 11. How they are computed, none of your business. Forget about it. Just remember, first factor is computing using all the items, not the like these 3. All the items are used to make the factor number 1. Now, step number 2, find out the coefficient of correlation of all the item and all the factors. Okay, compute this. It becomes a little bigger table. Don't worry, there's a method of putting it small, making it small. Yes, we got this table, a very important table, and let's take it to our Excel. Now, here just 1-2 things you need to pay attention to. These are the 11 items with 11 items, their correlation of every item with every other item. I don't require it, so let me remove all these 13 ones. At the bottom, check this. This is the point which was the fundamental why we used PCA. PCA is created so that none of the factor is correlated with the other factor. We can cross-check. We have done the computing of these are the factors, factor 1 to factor 11. And what is their correlation? A correlation of the factor with all other is 0. Okay, just for your checking purpose, let me remove this also. This is the table which is fundamental to our work. What this is? This is R. What is R? One item and one factor. What is a factor? Factor is computing by a calculation where all the 11 items contributed. Okay, done. This is the way. Now what should do we do with it? Now with it, we will do a little mathematics here. This is R and I will take the R square. That's it. I am saying let's compute the R square. So this is the R square. And if I get the total of these, it has to be 1. It has to be 1 and its name is, this will be called as communality. This will be called as communality. So what is communality? Just see what I have done. I have computed the factor score, okay, with a method unknown to you. Then I computed the coefficient of correlation of every item with every factor. Yes. Then I done the R square of that. R square is variance explained, coefficient of determination or the variance explained. Now, just see from here, what is communality? How much all the factors taken together explain the first item? How much first item is explained by all the factors taken together? So that is 100% has to be. Okay. And if I do the square here, it means this is R square 40% out of 100, 40% of the variation are explained of Q1. 57, this. So out of 1100 variation, remember where from 11 is coming. Please see the word percent, it means per 100. 40 out of 100, 0.57 out of 100, 63 out of 100, or 0.4 out of 1, 0.57 out of 1, 0.6 out of 1, 0.67 out of 1. So total out of 1 will come 11. Out of 11, this is done. This is called as the eigenvalue. And let me get the eigenvalue of all of them. Okay. And how much they will be? They should be 11 actually. Out of 1, out of 1, out of 1. If you divide it, this is called as the variance explained. Divide this value by number of items. And this particular thing is called as the variance explained. And then there is a, if you take the cumulative, this will be called as the cumulative variance explained. So let me do it at from this number to this number, it becomes cumulative variance explained. Now what exactly I'm doing, what these things are? Just see, when you say run the factor analysis, this is the backside calculation I have shown you. So we say go for the extraction, eigenvalue more than 1, great, and nothing else. Okay. So just check this out. It will say to us total variance explained. Okay, I have removed the initial calculations also should be there. Show the initial solution also. Look at the eigenvalue. Eigenvalue is 1. Yes, I got eigenvalue of 1. Then there is something called 5.524, 1.86, 1.14. Check this out. 5.5, 1.86, 1.4. Last value is 0.071, 0.071. Variance explained is 50.216. This is 50.216 multiplied by 100. And let me check this out. Is this okay? So this comes out as 50.216, 50.97, and so on. These are the things. Now, how many we should retain? How many of the factors we should retain? Because where is the data reduction? As many items were there, as many factors are there. So we have make a number of rules are there. One of the most prominent rule is where eigenvalue is more than 1. So I can see only 3 factors with eigenvalue more than 1. So let's remove the others. So let me remove the all other these of the things. The moment I remove these factors, these also are removed. Correlation is 0. And now what is this called now? This is 0.2727 is called the variance explained by 3 factors taken together, not all factors. Initially it was 1, now it is only 3. And that's why you will see here extracted 727, 783, 721. These are the values here. What do you understand by this? When this show you this table 634 minus 001, can you see this is the same table? It means when you work on the factor analysis, software by default compute the others also. Then on the basis of one, remove others and get the rest of the calculation. Now, if you look at it, factor 1 is highly correlated with almost all of the item. Just see here. Important point here is just not which item is got the highest one. Here the highest is 0.6. Here highest is 7, 795. This, it is highest. In the 3, this is highest, this is highest, this is highest, and so on. More than this, highest and highest. Actually, all of the factors load highly on the first factor, and it has to be. The technique is such. The technique is such that it's a very biased technique towards the first factor. And that you can understand by the simple fact that look how much first factor is explaining. 50% of the total. 50% only first factor is explaining and remaining 50 given to others. So it has to be most important. To remove this biasness, along with the PCA method, we have to use the rotation. So rotation is simply a method to improve the solution. So here just see, we said that wherever the values are there, don't show the value. 5.4 is 5.4, this, that is just deleted others. Now we will use one method called rotation to improve the solution. Generally, we start with the very max. Now what will happen, look at this table. It won't create the new variable, rather your variable variance is redistributed. 50% now becomes 28, 16.9 becomes 25, and 10.3 becomes the 24. But total is 77.577, 77.577. Total is not changed, redistributed. And you will find now there will be some better results. Some factors are going somewhere, some other factors are going somewhere. Since it will be difficulty for me to read, I need to check. So here is the some short method. Sort by size and express. Don't show me value less than 0.4. Now it will be somewhat clean factor should come. Yeah, there is a clean factor. If you say no, I don't want to see this one. Why this is showing me 4 also. Okay, so you can just opt to go for here and say 4, 5. Remember, you are expressing it. It doesn't mean the values are not there. You opt not to see those values. That's the only point. Now it's a clean one. Now the misnomer is people say first factor is made up of this, while the reality is first factor is made up of the items who are highly representing, highly correlated with the first factor. And this one is called as the construct. This is called as the construct. This is second construct. This is third construct. It means if you don't have an idea about how many constructs are there, you just collected the data. So how we actually start with? When we start with the scale construction, scale construction. So the first point is you need to write why a new scale. Why a new scale? So let me take one example from Professor Pooja Khatri's paper. She told me there is a scale of giving behavior. Why people give, there is a scale on that. But she is working on the alumni giving behavior. This is in the open source, paper is available. Professor Pooja is one of the prominent on workshops for skill development. Giving behavior, now alumni giving behavior, no scale is available. So can't we work on the same giving behavior for alumni? She wrote why it is not the same, why they are the different. Okay, now it comes, okay, then how should we start with? We got a lot of idea about the giving behavior, they might work. So the second point here is we go for the expert opinion. We go for the expert opinion and we ask them that please tell me, is it okay or not? Two methods are there. One is CVI and FVI, content validity index, and second is called as the face validity index. Okay, so I have some separate videos on the same. You can see on the YouTube. Using these, we reduce down the length. Maybe from here, you compute it from 150. Using this, you reduce to the 70 or something. After that, you go for the EFA, and my point starts from here. What EFA tells us? EFA merely tells us that these are the responses which people give alike. No matter, these are very, very different things. When the responses are same, their correlation will be high and they will merge together. People say, okay, they merged. On logical level, they remove. Are you getting this point? One is similarity by the respondent. Second is logic by the researcher. The two things are going on parallelly. Now, EFA is used for the data reduction. The things which are not logically fitting, you remove them, and then you cross-check by the CFA. And in the CFA, all we have, we call it as reliability and validity. Reliability and the validity. There are many methods of reliability and the validity, which I assume people in this session know. How many types of reliability, how many types of validity are there? Content validity, convergent, discriminant, nomological, predictive validity, okay, content validity, all of these validities. But where exactly we have paid attention to the wordings of the item? When we paid attention, the only attention was here in the FVA, face validity. Okay, what's the difference between content validity, face validity? Content validity means whether the content coverage is okay or not, whether we have covered all the items or not, which should be covered. And face validity means the language part, whether the language I have written proper, whether the words communicate the correct meaning. So face validity is only the language part, grammar part, vocab part. Content validity is the content coverage part. So we rely in this process heavily on the experts that they are our God. Whatever they are saying, that will be exactly the thing. IRT challenges that thing. IRT challenges that thing. It has its own say on the wording of the item, on the response pattern a lot. A response pattern tell $1 million things, which item response theory will tell us, which we generally, we do it in CTT also, but we rely on the expert opinion for the same. Okay, now the question comes, we understood a little bit about the EFA. At least we understood that the construct and the factor are not technically same. Though we call construct as the factor, and I always tell in my workshops, but when we talk about the session of the EFA, it gives very, very detailed. Generally, one construct is highly loaded in a factor. A factor is made up of all of the items. Construct is made up of the couple of items, 3, 4, 5 items are there. One factor is made up of all, but highly related with one construct. And the coefficient of correlation between them is called as the factor loading. Okay, so this was all about the CTT. I'm not touching the CFA part, etc. Any doubts to anyone in the CTT portion, please ask.
I have a question. Maybe I don't know whether it's relevant here or not. Sir, when we were doing factor analysis, you ticked on none, right? Because we want to see. We ticked, this method was none, na? The rotation method was none.
Rotation method very max.
No.
Initially, I ticked on the none.
Initially, yes.
Initially,
so when I just want,
so that I can show you what are the, at the back end, what are the calculations done by SPSS.
So I just want to know, so when we are choosing none, so that means there is no method of, rotation is missing.
No rotation is there.
Okay.
No rotation is there. So that's a highly biased one. You should never work. So it's not a point like whether I should go for rotation. With the PCA, you have to go for the rotation. Else all the factors will be loaded on the first factor only. It's a highly, highly biased technique.
And there is one, okay. Iteration karke bhi, sir, there was one.
That's okay. That's not a big thing. Iteration, it simply says it go for the calculations. So generally people say put a bigger number here. Okay. That's not a thing. When you do manual calculation, Pooja, then you understand what exactly I'm telling you.
That I've seen your videos.
So it is not required. The only point is, see, the limitation of the EFA is it will take together all the items which are highly correlated. Okay. Now, let me show you something here. I requested Professor Pooja if she can share her some data, and she was very generous in sharing. This is the paper, Consumers in the Realm of Higher Education, Student Wellbeing Scale. She made a new scale, and this is available on the open source. This is the way they worked with. So dimensionality of the item, dimension identification using focus group interview, deductive method, systematic framework based, item generation, face validation, content validity index. Okay, all of these she has done. Then verification using EFA. 102 items are taken. Students from 102 students are taken, then worked on that. Then there is the scale refinement using the EFA CFA, another 1034 students are taken. Okay, and then go for the nomological networking and go for the other generalizability, etc. Those things we are working with. But one limitation is if you note down where we are applying our judgment only in the expert opinion, how should be the language, how it should be. We are after that we are simply collecting the data from the people and we are relying on the statistics or this SPSS to do things for us, and we are taking the decision on the some values should be there, some threshold value should be there. IRT challenges this particular thing, and how we'll challenge, we'll go one by one. Okay, so let's start with the second step. If any questions are there, you may please ask. 1 hour is already over. CTT portion is done.
There was a question, I think, from Arun Kumar Dubey.
Yes, please.
Neeraj sir, thank you for allowing me to ask questions, sir. Sir, I have read a couple of methodological papers on EFA and even new papers that are coming in the domain of scale development. Increasingly, it is being argued that PCA is not a correct method for analysis as far as empirical testing of items are concerned, sir. So people are not agreeing with PCA. So scale development people say that PCA should not be used because that is not the right method in scale development.
I agree to those people.
Yeah, okay, thank you, sir.
For the reason is, the basic idea of the PCA is it will generate the totally uncorrelated factors. Totally uncorrelated factors are generated. So the basic idea is F1 and F2, their R is 0, and we have just cross-checked, yes, R was 0. PAF says, what is the common in the factors? So you must have seen, Arun sir, there is a exercise called CDS, Combined Defense Services. Our graduates, they go for getting into army. They are given some sort of group tasks are given. So what are the group tasks? Like these are the some things, and you need to take in them to the on the top of the hill. Resources are very limited, time is very, very limited, and you need to work together. The basic idea is not to take that wooden log on the top of the hill. The basic idea is to see the leadership, communication, how you convince other people. Those sort of things are there. So apparently what it seems, they are not important. At the back end, what is going on, that is important. So that is what is the common PAF technique is used. PCA is used only when you wish to go for the regression. Then PCA is okay. Because regression got a problem of multicollinearity, and multicollinearity is addressed by PCA 100%. You know, in the VAF, even less than 3 is allowed. But here we will say no, forget about 3. R will be 0, 100% 0, because second factor is made from the residual. So I agree, in the scale development, PAF gives something better results. And that's why in the first one of the point in the IRT, Arun sir, will be, please check whether which method is more appropriate, PAF also and PC also. It will work on the PF, but it will also show you that if you go for PCA, these results will be shown. I will come to that part also.
Thank you, sir. Thank you.
Okay. Let's then begin with Dr. Raja, any question from your side? If anything I'm missing or going too fast, something, please tell me.
Okay, no, that's fine. Perfectly fine.
Perfectly fine. Okay. Let's start with the IRT.